Knowledge graphs are the primary structure in ZEP. They represent a unified, dynamic, long-term context store that updates in response to new data. And it's from the knowledge graph that your agent retrieves the context that it needs. This video provides an overview of the ZEP knowledge graph, from data ingestion to context retrieval. You can ingest any kind of text data into a ZEP knowledge graph, such as chat messages between a user and agent, unstructured text such as documents, or even JSON. This means you can send user interaction data, documents, emails, transcripts, business data, or any other kind of text, whether it's structured, semi-structured, or unstructured, when creating a ZEP knowledge graph. This is what makes ZEP's knowledge graph a unified store of context. It can take in disparate types of data to create a factually consistent and unified source of truth. When you send a piece of data to a ZEP knowledge graph, ZEP automatically extracts the entities mentioned in that data, such as Jane, along with a summary of the Jane entity, and it also extracts any facts or relationships it finds in the data, such as Jane prefers morning meetings, and it integrates these new entities and facts into the existing knowledge graph. If the entity or fact already exists in the knowledge graph, ZEP merges them. And if a new fact, such as a user preference, contradicts or validates a prior fact, the prior fact is marked as invalid using the valid and invalid at timestamps that are on every fact in the knowledge graph. This is what makes ZEP's knowledge graph a dynamic knowledge graph, since it updates in response to new data and constantly maintains the current state of things, in contrast to traditional graph RAG. Additionally, ZEP maintains high retrieval accuracy and low retrieval latency even when the knowledge graph is very, very large. For more details on this, you can check out our research paper. This scalability of the knowledge graph is what makes it a long-term store of context, since ZEP maintains high-performance retrieval even for context from a long time ago. Lastly, you can give your agent access to the context in the knowledge graph through ZEP's easy-to-use context retrieval and assembly methods to make your agent more accurate, reliable, and personalized. I've just explained how ZEP's knowledge graphs provide a unified, dynamic, long-term store of context for agents to make them more personalized and reliable. To learn more about the knowledge graph and other key concepts, check out our other key concept videos.